Okay, good afternoon, class.
Good afternoon, sir.
So yesterday we discussed theorem 1, the proof thereof, and the period before that we dealt with the terminology of the Euclidean geometry rules and refreshing your memory with regards to previous theorems. So today we're going to look at exercise 9.1. I gave you the odd numbers for homework, okay? So what I'm going to do is I'm going to do those numbers quickly to show you the layout as required. I cut it already. Exercise 9.1 on page 278. Okay. So if you're not sure about something, just ask. And if you're not sure if your answer is acceptable or your approach is acceptable, please ask. Because sometimes people think that the geometry is in order, but they're doing things that is not acceptable in geometry. Okay? So to eliminate, to eradicate that issue, we're going to, you just ask your question and I'll try and answer it or clarify your misunderstanding. So in exercise 9.1, we are told given circle with center O and chord PQ. We got PQ. We are told that OR is perpendicular. So if OR is perpendicular to PQ, what do we know? We know that PR is equal to RQ. Why? Perpendicular from center to chord by 6 to 1. Then we are told that OR is 6, PQ is 16. So if PQ is 16, then RQ is 8. With that, I will be able to apply Pythagoras to get that. Not so? The question says calculate OQ. Alright? Remember, whatever is not on the diagram must be stated. Okay? You all okay with that? Alright, so let's go. OR is 6. We said PQ is 16. So RQ is going to be equal to PR, which is equal to 8. I don't need PR, so I don't have to state it. Okay? So PR is equal to 8y, perpendicular from center to chord. Perpendicular from center to chord by 6 to chord. Okay? Then, so we can put 8 in now. Now what do we know? Can I apply Pythagoras? What is the prerequisite to apply Pythagoras? The requirement. What do we need? Must be a right angle triangle. Is it a right angle triangle?
Yes.
Do we have two sides?
Yes.
So we're going to say that OQ squared, your hypotenuse squared is equal to 8 squared plus 6 squared. Your reason there is Pythagoras with angle R1 equals 90 degrees. Okay, very important. When you're busy with Pythagoras in geometry, you must state it. Okay? I know in trigonometry when we use the theorem of Pythagoras, we don't state the reason. We have to state the reason here. Okay? So that's simply going to give us 100. The square root thereof is going to give you 10 meters. You all okay with that? Any confusion? Right, let's move on. Alright, now we're looking at number 3. Circle with center O and chord AB. Circle center O to chord AB. OF is perpendicular to AB. So if OF is perpendicular, then AE is equal to EB. Why? Perpendicular from center to chord, bisect the chord. Okay, cutting AB at E with F on circumference. Then we are told that A is 8. So AE is 8. Then F is 4. Calculate the length of OF. So they want you to calculate basically the radius, in other words. They gave us a hint that OF equal OA equal X. Okay. So what can be worked out here? Remember, for the theorem of Pythagoras, I need to know what OE is in terms of X. Not so, it's the one unknown, it's the X the unknown. Okay, so what is OE, the length of OE? X minus 4, because that's your radius, okay? No reason required there, so that's dealing with the direct length. But if you want, you can put down the radius. Alright, so that's going to be x minus 4. Okay. Now can I apply the theorem of Pythagoras here? Yes. So what do I say? X squared equals 8 squared plus EO squared, which is x minus 4 squared. You all agree with that? X minus 4 squared. And the reason here is Pythagoras with angle E1 equals 90 degrees. So that's going to give me x squared equals 64 plus x squared minus 8x plus 16. That will cancel. That take 8x over becomes 8x is equal to 64 plus 16 is 80. No, not 80. Yeah, 80. Divided by 8 is going to give you an answer 10. Is that correct? Okay. So yeah, I didn't use the new theorem that was taught. Not so. There was a need for it. You all agree with that? Any confusion here? Yes? If AD. If AB. If AD, where's the D?
Okay, and the second question is, so you see when I say perpendicular from center to chord bisected, we have to say that also.
No, perpendicular from center to chord is suffice. Okay. Okay, anything else? Okay, let's carry on. 9.1, page 278, number 5. The question says, given O is the center of the circle, A, B and C, D are chords. OM is perpendicular to AB. So that means to say those lengths are equal. Okay? You see, it's not given equal here. So if we use the fact that it's equal, we must state it. If I'm not going to use it, I'm not going to write it as I did in the previous question. Okay? We are then told that OM is perpendicular to AB, ON is perpendicular to CD, which means to say those lengths are equal. Why do I mark that differently? It says those, CN is equal to ND, which is a different length to AM and MB. Okay? We are told that AB, that length is 30, so of course 15, 15 if needed, and OM is 20. Right? The question says calculate the length of OB. Calculate the length of OB. So OB is also what to us? It's your radius, not so? So I can use Pythagoras there. Not so? Alright? You all accept that if M1 is 90, it's the same as saying M2 is 90. No reason required. Not so? Because it's perpendicular, it's given perpendicular. So the 90 could have lied anyway. So no, I don't need to state that M2 is 90 angles on the straight. No, it's already included there. Okay. So the length of OB, so I'm going to apply Pythagoras in this triangle here. Okay. So where do I start? I start by saying MB is equal to 15. Why? Units. Why is MB 15 units? Perpendicular from center to chord bisects the chord. Perpendicular from center to chord. Okay. So this is now 15 here. Now what? Now I can apply Pythagoras, not so? So we say OB squared is equal to 20 squared plus 15 squared. The reason? Pythagoras with angle M2 equals 90 degrees. People, that's the most important part of that reason. If we leave Pythagoras out, it's fine. If we leave out the angle that's 90, you're definitely going to be penalized. Okay. So, that then gives us 625, I think. Let's check there. And OB works out to be 25 units. Okay? So there is 25 units. Now, in the B part of the question, the second part of the question we are asked, the length of CD, if ON is 15. So ON is 15, so CD. So CD is this whole length here. But I can't use Pythagoras for the whole length. Pythagoras will actually work out either CN or ND. Not so. But what is OC's length equal to? Sorry?
25.
Why is it 25?
Well, I said
It's your radius. Not so. The radius in the circle, anywhere in the circle, is of the same length. Not so. From center to circumference is your radius. So that's going to give us a length of 25. Okay? Is that enough information to apply Pythagoras? Yes, absolutely. It's enough information to apply Pythagoras. I'm going to pull this down a bit. Let's go with that. We're now going to say that 25 squared is equal to Cn squared plus 15 squared. You can say Cn squared is equal to 25 squared minus 15 squared, the same thing. The reason there is by Pythagoras with angle N1 equals 90 degrees. Okay. So Cn squared is equal to 25 squared minus 15 squared, which is 400. The square root thereof is going to be 20 units. Is that correct? But have I answered the question? No. So therefore the length of CD has to be equal to 2 times 2 times 20. So that's now also 20. Which makes it 40 units. And what's the reason there? Why can I say that CD and D is also 20? Perpendicular from center to chord. Perpendicular from center to chord bisects the chord. Okay, everybody guys understand? Don't never take geometry for granted. It's a lot of marks involved. Here is 2, 3, 4 marks. 4 and 3. So they give you 7 marks. Okay. Make sure you understand everything of geometry. And don't leave it till the last you say, no, I'm going to figure it out in the exam. No, what you guys normally say. Not this. Okay. Yes?
some example, like they didn't say that it's perpendicular. Some example, they say that the lines are equal.
If it's equal to the lines, then the lines are perpendicular. Yeah. If they tell you it's perpendicular, then the lines are equal.
They want to do reason B flat.
Did you watch the video?
So I didn't understand.
Okay. But you watched the video. Strange. Later, but you see that. You see. So when you left here, you had a choice. You want to watch the video down to understand. You didn't watch the video fully, now you don't understand. But your line, if the lines are perpendicular, okay, it was given perpendicular, and then they bisecting, then the lines are equal. If they are given equal, then the lines are perpendicular. So it's the reverse. So here's the theorem. If you had watched the video, or if you had stayed to watch the lesson, then you would have gotten this one. If that is given as 90, this is now not here. If it's given as 90, then AM is equal to MB. Why? Perpendicular from center to chord bisects the chord. Then that means you said that's equal. If that is given equal, this is your question. If it's given equal, then you can conclude that OM is perpendicular to PQ. Why? Bisector from center to chord. That is your reason. Bisector means, to say cut in half. Bisector from center to chord is perpendicular to the chord. People question 7, 2 circles with center M. 2 circles, both centers of the circles are M. PT is a chord of the larger circle cutting the smaller circle at Q, which is this point here. then Q and S. Then MR is perpendicular. So if MR is perpendicular to TP, then one can be concluded here that peak R is equal to RS. Why? Perpendicular from center to chord bisects the chord. As well as QR is equal to RS. Why? Perpendicular from center to chord bisects the chord. Okay. So what happens now is we are given PM. PM is 17. MS is 10. So the radius of the smaller circle is 10, of the bigger circle is 17. And QS is 12. QS, that is 12. The question says calculate the length of MR. MR. So I'm going to work in this triangle here. So I got 10, I can say work out RS and I can calculate MR with it. Not so. So we can say that RS first is equal to 6. Why? Perpendicular from center to chord. Perpendicular from center to chord bisects the chord. So that is now 6. So is enough information to apply Pythagoras? Yes. So we can say now that 10 squared is equal to 6 squared plus MR squared. Why? Because of Pythagoras with R1 equals 90 degrees. So that MR squared is equal to 100 minus 36, which is 64. So MR works out to be 8. So that's 8 units. Okay. Now, in the next question, of course, I want you to work out PT. PT. Which is the whole length here. But we can't work out the whole length here. Not so. What, you finger up? It's not up anymore. Okay. But you can work out PR. Not so. Is enough information to work out PR? Yes. So we are told now that PR squared is equal to 17 squared minus 8 squared. Why? The Pythagorean theorem with R2 equals 90 degrees. It was given 90. Or perpendicular, so it has to be 90. So this works out to be 2 to 5. The root thereof is 15. Not so. 15 units. But have I answered the question? No. So therefore PT is equal to, if that is 15, that has to be 15 as well. That's our length now, no? Why? Sorry? Perpendicular from center to chord bisects the chord. Okay? Any confusion here? No? Let's carry on. Question 9. Given circle center O with parallel chords A, B and C. EOF is a straight line. Then we are told that A is equal to EB. So if A is equal to EB, what can be concluded from there? EF is perpendicular to AB. Why? Bisector from center to chord is perpendicular to chord. Okay. So perpendicular from center to chord. Bisector from center. Then we are told that AB is 14. AB is 14, so that is 14. So 7, 7 if needed. Okay. EF is 39. So from there to there is 39. Then we are told that OC is 25. What is also OC? OC is your radius. So that is your radius, that is your radius, that's your radius. So all these lengths from center to circumference is going to be your radius. Why do I take it specifically to those points? So that I'm forming triangles. Can you see that, people? It's your radius, your radii. Then we are told that EF is 39. Whoops, pause that. First question, prove that F1 is 90 degrees. Prove F1 is 90. Right, so where do we start? we can start with E1. Not so? E1 is 90. Why is E1 90? Sorry? Bisector from center to chord is perpendicular to chord. Okay? Bisector from center to chord is perpendicular to the chord. So there's 90. Now what can we say? So F1 is equal to 90y, which is answering the question. But why is F1 90? Yeah, that what is that? There we go, yes. Co-interior angles are supplementary. Co-interior. And what must we add? Let's add that AB is parallel to CD. She's saying that. If you want, you can first say that 90 plus F1 equals 180. And then you say F1 is equal to 90 degrees. Why? Co-interior angles with AB being parallel to CD. You guys got it? So there's 90. Alright. B. The B part of the question says calculate the length of OE. So OE, which is this length here. But we know what OA is. What is OA? 25. Why? Radius. You see, do I have to say this? Yes, because it's not on the diagram. Not so. They didn't tell us that OC was your radius. So we have to state it. We know now that is. So that is 25. What else do we need? AE. What is the length of AE? 7. Why is it 7? Perpendicular from center to chord by 6 to 4. No? Given. It's given. What is given? That AE is equal to EB. Or we could have said given that E is the midpoint. The same thing. Not so, people? We could have even used bisector from center. Because at this point we highlighted the theorem already. Or we could have said bisector from center. Okay, but that's not going to help us. We could have said perpendicular from center. Okay. So that's going to give us 7. Can I apply Pythagoras now? Huh? Yes, absolutely. So let's go with Pythagoras. It's going to be OE squared is equal to 25 squared minus 7 squared. Reason? Pythagoras with angle E1 equals 90 degrees. So what does OE work out to be now? So it's going to be 625 minus 49. Is 200 and? 625. 625 is 578, I think. 577. Sorry? 176? Oh, 576. The square root thereof? 24. So that's going to give you 24 here. Are you sure, no? 25 squared minus 7 squared. 576, the root thereof is 24. Okay? So what I'm going to do is I'm going to just move this up a bit. I need this to move down, of course. Can't move too much down. Okay. So the next question, I think I must take this off. I'm going to take A off. Okay, so C says calculate CD. Now CD is this whole length here, not so. So I can't calculate CD. What can I calculate? CF, because I know that that is given as 25. Do I need to state it that CO is 25? No. Why? It was given to us. The only things that we state is the stuff is not on the diagram. You guys understand? Right, so that's 25. Well, how do we calculate OF? I'm going to calculate this length here. It's going to be 39 minus 24. Do I need a reason? No, it's to do with length. Okay? Then what is 39 minus 24? 15. There's 15. So how do I calculate CF? So CF squared is equal to 25 squared minus 15 squared. The reason is Pythagoras with the angle F1 equals 90 degrees. So work that out. Sorry? 400. 20. Okay, but have I answered the question? No, so what's the question? Let's calculate CD. So therefore CD is going to be double that. So it's 20 here, 20 there. Why is it double that? Because perpendicular from center to chord bisects the chord. Okay? Any confusion here? Alright, let's carry on with our lives. Number 11. In question 11, we are given that PQ is a chord of the circle center O. So PQ is a chord of circle center O. ROQ is the diameter. So if ROQ is the diameter, what do we know? That OQ is equal to RQ. Why? RO. Why? Both is going to be radii there. Not so. So what triangle is being formed here? We've dealt with this theorem last year. The midpoint theorem will come into play. As you can see that these lengths are equal and those lengths are equal here. So which means to say that will be parallel to that. Not so? And SO, twice SO will give you PR's length. Not so? And the reason is going to be the midpoint theorem if we're going to use that. Not so? Aye. Sorry? Solve the argument. So the question says you must prove that angle P is 90 degrees. So we must prove that is 90. Alright, so what can we say from here so far? This is given equal. So what do we know? We know that S2 is 90. Why is angle S2 90? Bisector from center. So if that's 90, now what? So if we can prove that SO is parallel to PR, then corresponding angles. Not so? But can we just say it's parallel? No, we must just prove the midpoint theorem we can work with. Not so. So we say, for the midpoint theorem, it must be the two centers that's connected. Not so. So we say that SQ is equal to SP. Where do we get that from? It is given to us. Right. Then we spoke about QO and OR is equal. Why? Radii. Not so? That is equal. So is that not the midpoints connected? Yes. So therefore, SO is parallel to PR. Why? Midpoint here. You think I highlighted that yesterday, isn't it? No. Everything's for a reason. So if that is parallel, now what can we conclude? Therefore, PR. What? PR. Angle P. What's wrong with you? Okay. Oh, you said P. Angle P is equal to 90. Why? Corresponding angles are equal. Corresponding angles, and what was I saying? SO is parallel to PO. And then we have proven it. Okay? That brings us basically to the end of that exercise. So your new theorem is so for homework I want you guys to do the even numbers, okay, of 9.1, the even numbers. So now we're going to look at theorem 2. In theorem 2 we are told, oops, so here we are told about subtended angles. I'm just going to cut this quickly. And this is on page 280. We're using the Clever Maths textbook, okay. Keeping math simple. Okay, subtended angles. At this point, we need to define the word subtended. Okay? We talk about chords, a chord or arc subtending an angle at the center or circumference of a circle. Okay? In the diagram, the minor arc AB, which is this part here, the minor arc AB, subtends angle O1 at the center O. And it also subtends, you see this arc here? The minor arc is also subtending angle C at the circumference. Can you see that, people? So, think of AB supporting the angle at center of, or at the circumference of circle O1, and angle C stands on the chord of AB. So in other words, you can look at it from this arc, or it's like they're saying the arc AB is supporting or giving off an angle at the center, O1, or an angle at the circumference, which is also angle C. Okay? So subtends means to say basically to support the angles. Okay? You guys understand? Okay? You're going to hear it a lot, so it's going to become part of your vocabulary. Okay? If you look at this, at the major, that was a minor arc. If you're looking at the major arc, it's going to look something like this, yeah? Let's get this out. Which will then go into theorem 2. Just cut it. Okay, in this diagram, the major arc AB. You see here, the previous diagram was the minor arc. Here's the major arc. Can you see that, people? The major arc AB is subtending the angle O1 at circumference, and also this arc here is subtending angle C at the circumference. Did I say circumference here? AB is subtending O1 at the center, and AB is subtending angle C at the circumference there. Okay. The major arc AB supports O1 at the center and angle C at the circumference. That's basically what they're trying to highlight there. Now we're going to theorem 2. This is also a proof theorem, so you need to know this for examination purposes. Okay. Yesterday's theorem and today's theorem, it needs to be known for the upcoming exam and for exams to follow. Okay. So write this down so long. I'm just going to take this out here. As you can see, it's the asterisk there, so it's a proof theorem. This theorem is worth 6 marks in your exam. Okay. Yes? So at times I can ask you, yes? Why are you calling the birds? Right, write this down. Come, start making jokes. Okay. So here we are told an angle that an arc of a circle subtends at the center of the circle is twice the angle it subtends at the point on the circle's circumference. Given. We are given the fact that a circle center O, the reason why I drew it was because the diagram itself, the picture, has a lot of markings on it already. So I don't want to confuse you, okay? This is how it's given. You have a circle, center O, and arc AB. That's now your arc AB. Subtending AOB, which is this angle here, at the center, and ACB at the circumference. The question is, you are required to prove, RTP means to require to prove, that OAB, this angle here, is double that angle there. Okay, you guys understand? So we are trying to prove that AOB is equal to double angle C. Right, you guys got it? So as indicated in yesterday's lesson, that every theorem that we prove in analytical and in Euclidean geometry, there must be a construction. For those of you who listen, there must be a construction. Okay, so we start off with a construction. So we're going to construct CO produced to D. Okay, so we're going to construct line CO, and produce means to say extended to D. So firstly, there's your line going through O to D. Alright. Can you see that, people? So which means to say now what is formulating here is that that's C1, C2, D1, D2. C1, C2, O1, O2. Okay. So now, the proof. Alright. What can we say about angle O1? What can we say about angle O1? Angle O1 is equal to angle C1, yes, plus angle A. Why is angle O1 equal to angle C plus angle A?
Isn't that not inferior, exterior?
Yes. It's going to be exterior angle of triangle. Exterior angle of triangle equal the sum of the two interior opposites. Okay? Exterior angle of triangle, and making the dots there suffice for exterior angle of triangle is equal to sum of the two interiors. Normally we name the triangle that is the exterior angle of, and is the exterior angle of triangle as COA. Okay, you don't have to write that. So people, C1 is equal to angle A. Why is angle C1 equal to angle A? Who can tell me? Good start. Yes, radius.
And that CO is equal to AO.
And there we go. So your reason here is angles opposite equal sides. Not so? And it's coming from the fact that it's your radius. Angles opposite equal sides. I must mention the radius. Otherwise you have to say OA is equal to OC, radii, and then say angles opposite equal sides. But it's going to just be easier to mention this your radius. Not so? So therefore, angle O1 is equal to C1 plus angle A, which is also C1 from here. So what's C1 plus C1? 2C1. So therefore angle O1 is equal to twice C1. You all okay with that? Alright, let's carry on. So now, whoops. Okay. So now let's work in the other triangle. We're going to work in triangle COB now. So what can we say about that? COB. We can say that O2 is equal to what? O2 is equal to C2 plus angle BY, exterior angle of triangle, dot dot dot, and it's triangle COB. Okay. So what can we say about C2 and angle B? C2 is equal to angle BY, angles opposite equal sides. Why?
Good afternoon. Can I have your attention
Radius.
to the notices, please?
So therefore,
Fontwana, can you come to the office, please?
O2
Sujama?
is equal to
Dance practice is cancelled
Mhm.
today because of the preparations in the hall for tomorrow. There will be no dance practice this afternoon. The following girls, can you go see Mrs. Patel for an urgent connection after school? That will be in her classroom, room 42. The Letha Nutchaka.
Okay, let's just wrap this up quickly. So O2, we said O2 is going to be twice C2, not so? Right? But now what's going to happen is, if I add O1 plus O2, that is going to, if O1 plus O2 will be equal to 2C1 plus 2C2. Not so? So what is O1 and O2? O1 plus O2 is actually AOB, not so? So I can conclude therefore AOB, but take 2 out as a common factor here. Then I'm left with C1 plus C2, not so? But what does C1 and C2 entail? ACB. Can you see that? So I can say that's going to be twice angle AC. And if we use this theorem, you will say angle at center is 2 times the angle at circumference. Angle at center is 2 times angle at circumference. Okay. People go over the theorem again. It's worth 6 marks. And you need to know it for your upcoming exam. People enjoy the rest of your day. Good afternoon, class. Don't forget the homework, okay?